All right, so now we're going to switch our attention to stem cells, and I'm going to try to get you to see a few very simple ideas that will orient you. When you look closely at illness, any disease, there's a common denominator of all of them, and that is cell damage. There'll be dead and dying and injured cells for any disease, okay? If you get a stroke, you're killing brain cells. If you get a heart attack, you're killing heart muscle cells. If you get hepatitis, then you're going to injure and hurt your liver cells. Even a fracture causes the death of bone cells, okay? Arthritis always destroys and injures cartilage cells, okay? So every illness has cell damage, all right? If there's no cell damage, you're not sick. Okay? Moreover, if those damaged cells are not replaced with healthy new ones, you don't get well. Okay? I think I forget the philosopher, but he defined medicine as the doctor entertains the patient while nature cures the disease. Well, that's exactly what happens. That is true. So it's the adult stem, which I'm going to tell you what that means. It's the adult stem cell system that heals you 24 hours a day from cradle to grave. It's always going on, okay? You would die if that couldn't happen because you're losing cells just wear and tear, never mind when you get sick or hurt. And ergo the title of my book, Cells That Heal Us from Cradle to Grave. All right. What makes a stem cell rather than a non-stem cell is reproduction. Now, most cells in your body reproduce in a way where the cell that they make looks and acts exactly like the cell that made it. That's called linear reproduction. Stem cells, on the other hand, do something whereby they make a cell that's different from itself. And that is actually literally called the lineage stems. And that's where the term stem cell comes from. There's a stem in the lineage of the cell. It's a different type of cell. So stem cells make cells that are different from themselves, and it's usually shown as like a tree with branches, but it's usually upside down, okay? And here's where we knew, back when I went to medical school over 30 years ago, we knew about stem cells, but what we knew was wrong, and here's what it was. There are stem cells in the bone marrow that make blood, because one type of stem cell can make all the types of blood, white cells, red cells, platelets, different white cells, lymphocytes, the whole thing is made from a common branch, okay? We also knew that when the sperm fertilizes the egg, the ovum, it makes a single cell called the zygote. Well, this is the king of the stem cells because this cell is going to make all 230 cell types in the body. So it's going to branch and branch and branch until all those types of cells are available to be used in the body for different functions. The first step is microscopic, and you get a ball of cells, okay? And you can take one of those cells out, and I'll show you in a minute. But since these cells make an entire baby in only 9 months, you're going from one cell to trillions of cells, 7-pound baby in just 9 months. The problem is, with that kind of cell growth, that is ferocious cell growth, no cancer in medicine can make a 7-pound tumor from one cell in only 9 months. It's so fast. So when you take one of these cells out of the embryo, each one can make a whole baby, but once it's out of the control of the embryo, it makes cancer every time. Now, you can do biotechnical things to them so they won't make cancer. And every one of those biotechnical things that you have to do before you're injecting any of these into a patient, each one is a patent. And so when these embryonic stem cells finally get beyond the delay that the FDA and those that want it delayed, when they're through of it, this is going to be about 10, 20 years from now, at the least. And they're going to be so expensive, nobody, including me, is going to be able to afford them because they're going to be so heavily patented, okay? That's why I don't like embryonic stem cell science. In fact, the industry is broken up into embryonic stem cell PhD scientists, and then adult stem cell scientists are all doctors. They're all physicians because they understand that they can be used and are totally and utterly safe. But the stink from embryonic stem cells, because of the religious issues and the fact that they're cancerous when you take them out of the embryo, has stunk up the reputation of adult stem cells. And if there's anything I'm doing here to tell you, is that these two things are vastly different from one another. The doctors that do the embryonic stem cells don't even talk to the doctors that are interested in adult stem cells. They don't even like each other. They work for different bosses and they get their money from different sources. And I think that the embryonic stem cell folks are crazy. They're following the wrong path, and that's why we don't have today the treatments that we brought overseas. So here's the difference between the adult stem cell and the embryonic stem cell. Here's the little ball of cells, the very early embryo, and it begins to branch, stem into all the different cell types, okay? And about when it gets to here, there are no embryonic stem cells left. They've all changed into something else. If the embryo is no longer microscopic, there are no embryonic stem cells there. It's something that you get only from the very early bag of cell microscopic stage. But as they keep reproducing, that line is the baby's birthday. And everything above that line are prenatal cells, and everything below that line are adult cells. There's trillions of cells, but there's only 220 different types, all right? Now, among these cells below the line, which are all adults, there are some cells that still can make cells different from themselves, and those are the adult stem cells, okay? And we know they're in blood and make blood elements. And that's all we knew in 2000. In the year 2000, we knew there were stem cells that make blood and there are stem cells that make babies. We didn't know there were stem cells that healed the body 24/7. We didn't know that. That was the big discovery, okay? Now, we know that the bone marrow is healing the body with its stem cells 24/7. Now I want to tell you how we found that out, how we figured that out, okay? And that's going to be that when babies got leukemia, they just died, okay? For years and years, and they tried everything they could think of. But leukemia is cancer of the bone marrow, okay? So blood, bone marrow makes blood, bone marrow, cancer is leukemia. We know we can get rid of it by radiating the patient and chemotherapy. But now what are you going to do about a bone marrow? These little kids got very sick, and without a new bone marrow, they're going to die. You can't live without an immune system. You can't live without your own blood. So what they did is they made the whole thing work by transplanting someone else's bone marrow that was closely related so that they would HLA match enough so that the bone marrow wouldn't get rejected. okay? And that's how these kids survived, and they've been doing this for decades now. Very, very successful. Mainstream American medicine, okay? So here's how we figured this out. You might recognize this face. This is someone who was very public about her bone marrow transplant. Robin Robinson on Good Morning America. And so she's going to go on and live many, many, many years, okay? Because she no longer has her bone marrow problem, her cancer, her leukemia, and she's got a new bone marrow, all right? If you were to wait those many years that she's going to live happily and then do a post-mortem exam on her brain and her liver and her heart, if she got a male donor, all those cells that were put into her will have a Y chromosome, and we can trace that. So if they did a postmortem on this patient, they would find Y chromosome brain cells, Y chromosome heart cells, Y chromosome lung cells. Because as she goes through the years and she gets sick or cells die, they're constantly being replaced by her now male bone marrow, adult stem cells, okay? The other way we know that this is happening is that when you take a heart from a female patient and put it into a male, they do biopsies on heart transplants all the time, and they will continually have more and more Y-containing heart cells. Same thing with liver transplants, lung transplants, they get filled with Y chromosome containing cells to replace the issue when anything kills some of their cells. This is also seen in nature. It's called maternal microchimerism. Every mother has cells, adult stem cells, from all her babies. And if the baby is a male, we can trace those cells because of the Y chromosome amongst all her body cells, which are all XX. So if you take any mother here that's any time had a male baby in the past, if you were to biopsy any of the body tissues, the lung, you would find Y chromosome male lung cells, liver cells, heart cells. Mayo Clinic did a study and found this out. So if they're getting a shot of youthful stem cells when they're pregnant, you would theorize maybe they live longer, as opposed to women that don't have any babies. And in fact, they did a study on that and found that up to 9 babies, you're going to live an extra almost a year for every baby. Up to 9. After that, the stress becomes negative.